Hello and welcome, distinguished guests and fellow innovators. I'm Yogesh Siadri, and alongside me are my esteemed colleagues Mansu Thapa and Srinivas Lupongati. Togetherly, we stand at the forefront of a pivotal moment in automotive technology, enhancing fuel efficiency through the power of advanced analytics. And moving forward, in today's session, we embark on a journey through the intricate world of predictive and prescriptive analysis. Our mission to forge a path towards vehicles that not only perform better but also tread lighter on our planet. As we navigate through complex data sets and innovative models, we uncover insights that challenge conventional wisdom and redefine what's possible in the fuel economy. So the journey is about more than just optimizing fuel consumption. It's about driving change and pushing the boundaries and setting new benchmark for sustainability in automotive industry. So buckling up and getting ready for the enlightening ride into the future of vehicles, designing and efficiency. And thank you once again for joining with me today. And your engagement fuels our exploration and innovation more overly. And going ahead, the journey through the rich history of vehicle fuel efficiency. Our exploration begins in the shadows of the oil crisis and stretches into today's urgent calls and sustainability. This story is not just about the evolution of engines and aerodynamics. It's about a relentless pursuit of innovation and amid the global challenges. As we shifted through a decade of data and breakthroughs, we connected dots between the past research on our current objectives. This treasure trove of insights from engine technologies and to hybrid systems has been instrumental in shaping our approach. And going today, we stand on the shoulders of giants, pioneers. We have paved the way with their groundbreaking work in automotive efficiency. Our projects this builds on the legacy, using historical wisdom to propel us towards smarter and cleaner through the vehicle technology. And let's getting dive into how these insights have powered our analytical models and it guided us towards a future where cars can drive further and faster and like the greener in a sustainable way. As we move forward, let's pinpoint the challenge at the heart of a project. Today's automotive industry stands at a crossroads, driven by escalating fuel prices and rigorous environmental regulations. The demand for fuel efficient vehicles is not just consumer preference, it's like a global imperative. So despite advancements, the average vehicle fuel efficiency has not kept pace with these demands. The gap between this current capabilities and regularity expectations continues to widen, posing a significant challenge for manufacturers and consumers alike. And the project addressing this majorly pressing this issue by harnessing advanced analytics to just bridge this gap. We aim to transform this radar the raw data into actionable insight that can lead to more fuel efficient vehicles, optimizing vehicle design or by the performance. And we not only meet but anticipate the evolving needs of the market and the environment. So togetherly we explore how our innovative approach can turn this challenge into an opportunity for the breakthroughs in the fuel efficiency majorly. In tackling the challenges of fuel efficiency, our approach uh, bifurcates into two distinct yet interconnected pathways. So predictive analysis and prescriptive analysis. Predictive analysis, here we have designed a sophisticated model that uses historical data to forecast fuel efficiency based on vehicle specification. This model doesn't just predict it, it reveals which factors most significantly impact miles per gallon. And our goal is to provide a clear picture of how different design choices affect fuel consumption. And going to the prescriptive analysis, it armed with predictive insights, so we shift to actions. This stage is about applying our findings and to suggest optimal changes in the vehicle design by adjusting variables and to be taken as engine size, weight, and the displacement of the vehicle and acceleration. Some of the variables Our model like is to identify and configuration the maximize fuel efficiency without like compromising the performance. So through this dual lenses, so we are not like just reaching the to the trends, but actively shaping the future of like automotive design. And by these like we will can figure out like how like our models provides a roadmap of like for building vehicles that lead the market efficiency of like the sustainability. As we embark on this analytical journey, our first step was to secure a robust dataset that could underpin our models. With accuracy and depth, we turned to the comprehensive Kaggle vehicle dataset, renowned like for its like extensive coverage of vehicle specifications. This dataset serves as like a cornerstone of our analysis, featuring detailed information on the key factor like influencing the fuel efficiency, like majorly miles per gallon. So our primary target variable representing fuel efficiency, and other variables like cylinders, weight, displacement, and horsepower and acceleration. A critical explanatory variable that offers insights into how like various features impact miles per gallon. And our meticulous selection process like ensure that the data was not only like vast but also like varied, encompassing like a wide range of makes, models, and configuration which focuses. So this diversity allows us to explore and like understand the nonce dynamics of fuel consumption across the different vehicle types. So in this like upcoming phase, like the project like this data sets did not just like inform like our models, it's like shape the term and enabling a deep dive into the complex or like interplay of like vehicle attributes and their effects on the fuel efficiency. And delving into the heart of our project, the data exploration phase, like where we began to unravel like complexities of vehicle specification and their impact on fuel efficiency. So as we can see, like we have utilized a variety of analytical techniques to ensure like the data set and pristine, and our findings are like are robust. So box plot, like we actually began with this box plot for each variables like miles per gallon, cylinders, and weights, and to identify any outliers. This step is like crucial, as outliers can significantly skew of our results, like leading us to like inaccurate conclusions to be. So next to the histogram, like we examine and the distribution of our key variables through histograms. This allowed us to like understand the spread and central tendencies of data like horsepower and acceleration, providing the insights into the typical vehicle like characteristics in our data set. So next to the scatter plot matrix, so perhaps like the most like telling the scatter plot matrix here like illustrates the relationship between all pairs of variables. So each plot helps us to like visualize like how one variable like affects another. For instance, like how weight might correlate with like miles per gallon, or like how engine displacement like interacts with the horsepower. And going on to the like correlation matrix, so to complement like our scatter plots, like the correlation matrix with like heat mapping, like in the upcoming slide we can quickly identifying the strength and the direction of relationship between the variables. And like the darker shades like indicates in this like stronger correlations, and guiding our like focus to the most influential factors on the fuel efficiency. In the data transformation phase, we shifted our focus from like exploration to preparation, ensuring like our data set was primed for the sophisticated analytics to the follow how we transform the raw data into a model or ready format. So dropping the columns, so we began like just by eliminating columns that did not contribute to our analysis. So this step like which was crucial for reducing complexity and improving the efficiency of our models and removing the outliers. So it's like our initial exploration, so we identified and removed outliers that could like potentially distort like our predictive accuracy. So this was like essential for like maintaining the integrity of our results. And next to the data partitioning, and to train our models effectively and validate their performance, we split the data into training and testing sets. So we used an like 80 by 20 split, so a standard practice that balances training depth, like with sufficient testing to avoid overfitting. Each of these steps was meticulously executed and to enhance the quality of our analysis. So by refining our dataset, we not only like increase the accuracy of our models, but like also ensure that the insights derived would be both reliable and actionable to do. As we moved into the model building and evaluation phase, the focus shifted towards constructing a predictive model that could accurately forecast fuel efficiency based on the like vehicle specification. So model development, like we employed a linear regression model, choosing for its ability to provide clear insights into how each variable, such as like cylinders and horsepower, directly impacts miles per gallon. So this model was developed using the refined dataset, ensuring that the inputs like were pristine and predictive. So the formula like which was displayed here miles per gallon, that's implies like 46, and for cylinder it's like 0.392 and 0.0007 like for the displacement, and 0.040 horsepower and weight is not 005, and acceleration is 0.002, which encapsulates the relationships like we discovered, and it highlights the negative impact of the increasing engine size and power of fuel efficiency, while also qualifying the effects of like vehicle weight and acceleration. And ongoing to the model evaluation, we evaluate like the model looking onto several metrics including R squared, and which quantifies the variance in miles per gallon explained by our model, and like R squared of 0.85 for instance suggests that our model like explains 85% of the variation in the fuel efficiency across the dataset, indicating a high level of predictive accuracy. And it's also like employed a cross validation techniques to ensure that our models like prediction were not just a fluke of a particular sample. This helped us confirm the model uh, robustness across different subsets of data. Our predictive model demonstrates high accuracy with an R-square value of 0.85, effectively quantifying how vehicle specifications like cylinders, displacement, horsepower, weight, and acceleration impact fuel efficiency. And this robust model not only confirms the influence of these variables on miles per gallon, but also provides actionable insights for optimizing vehicle design to enhance fuel economy. And after successfully developing and validating our predictive model, we transit to the prescriptive analysis phase. This stage is like where we apply our predictions to real world applications, suggesting actionable changes to vehicle design that can lead to optimal fuel efficiency. And the objective is like the primary goal here is to utilize the insights gained from our predictive model to formulate recommendations for the vehicle in the manufacturing that maximize miles per gallon without compromising the performance. And the applications of the model insights using the regression model, we identify the key variables that have significant impacts of fuel efficiency. For instance, like reducing weight and engine size were seen as a pivotal in increasing miles per gallon. Based on these findings, we employed optimization techniques to prescribe specific changes in vehicle specifications. We adjusted factors such as the number of cylinders, displacement, and overall vehicle weight, aiming to find a balance that yields the highest fuel efficiency. And the results and recommendations, the analysis revealed the strategic modification in engine design and vehicle build could enhance miles per gallon by up to 30% under simulated conditions. So we developed a set of guidelines for manufacturers that outline the optimal ranges for each key variables. For example, reducing the number of cylinders or decreasing the engine displacement with specified limits could significantly boost efficiency impact. So on this perspectives, recommendations are designed not only to improve current vehicle design, but also to guide the future innovations in the automotive industry. So they provide a clear pathway for manufacturers looking to meet the stricter environmental standards and consumer demands for high efficiency. So this prescriptive analysis bridges the gap between the theoretical data, uh, science, and practical engineering solutions, offering a roadmap for sustainable vehicle design majorly. Building on the foundation of a predictive and prescriptive analysis, we reach a critical milestone in our project, like the calculation of optimum miles per gallon. This stage illustrate practical impact of implementing our recommendation in vehicle design and specification majorly. So the methodology that we utilized in the prescriptive insights gained earlier. So we applied a combination of linear programming and simulation techniques to fine tune vehicle attributes to the ideal states majorly. So we meticulously adjusted variables like the number of cylinders, engines, displacement, vehicle weight, and aerodynamics, each with practical and technological feasible limits that we discussed earlier. So the achievements uh, culminated in achieving an optimal miles per gallon of 26.25. This represents a significant improvement over the baseline miles per gallon figures typically observed in similar uh, vehicle categories, which often have around 23 miles per gallon. So this 14% increase in the fuel efficiency not only showcase the effectiveness of a model, but also sets a new benchmark for future vehicle designs to be. So and the graphical representation displays the bar chart and comparing the baseline miles per gallon values against our optimized results, visually representing the substantial enhancement achieved in analytical interventions. So these implications miles per gallon levels have profound implications for the automotive industry, so demonstrating the tangible benefits of data driven vehicle design majorly. So not just in terms of fuel economy, but also in reducing the environmental impact or operational costs for the consumers majorly. So translates less frequent trips to the pump and and low fuel expenses over the vehicle lifespan they were using. And this access validates the power of advanced analytics and redefining the performance standards and propelling the automotive industry towards a greener and more efficient future to be. Our exploration of vehicle specification and their impact on fuel efficiency on the most illuminating tools has been the correlation matrix. So the matrix which was helped us visualize and quantify the relationship between key variables majorly. So understanding to the correlation matrix, the matrix displayed here use varying shades to indicate the strength of the relationship between variables. So the darker colors represent stronger correlations, whether positive or negative. So for instance, as shown, there is a stronger negative correlation between vehicle weight and miles per gallon. So meaning as weight increases, miles per gallon typically decreases. This is intuitive, as heavier vehicles requires more energy to move. So insights to be other notable findings from our matrix include the relationship between engine displacement and horsepower with miles per gallon. Both show negative correlations, suggest that larger engines and horsepower, a high horsepower, while providing more power, tend to low fuel efficiency. So conversely, variable engine efficiency shows positive correlation with miles per gallon, indicating that improvements in engine technology can directly enhance fuel economy. So applications correlations are crucial for predictive modeling, as they inform us which variables to adjust in order to optimize miles per gallon. So also support a prescriptive analysis by highlighting specific areas for improvement in vehicle design, such as reducing weight or optimizing engine size without compromising the performance. So understanding these all aspects, correlation allows automotive designers and manufacturers to make informed decisions that balances power, weight, and efficiency to meet the consumer demands and regularity standards for the fuel economy. And this correlation matrix is not just a statistical output; it's a roadmap that guides our the entire project, helping us to pinpoint effective strategies for enhancing the vehicle fuel efficiency majorly. As concluding the presentation, let's reflect on the journey we have undertaken and the milestone we have achieved through the predictive and prescriptive analysis. Our research began with a deep dive into historical data, which we uncover significant trends and relationships that set the stage for our predictive modeling. So developed a robust predictive model that accurately forecast miles per gallon based on various vehicle specifications. So achieving an R squared value of 0.85, indicating a high level of predictive accuracy. And employing this model, conducted a prescriptive analysis that recommended like a specific change with the vehicle designs, and recommendations were geared towards the optimizing fuel efficiency without like compromising vehicle performance. And the pinnacle of the project is realizing an optimal miles per gallon of 26.25, significantly higher than industry like averages, showcasing the effectiveness of our analytical strategies. So implications, and this like impact findings not only enhance our understanding of fuel efficiency, but like also pave the way of innovative approaches to automotive design. And integrating these data driven insights into vehicle manufacturing can help the industry meet increasingly stringent to environmental standards, while also addressing consumer demands for more efficient cars. So the future prospect is looking forward is always like encourage further exploration into additional variables and newer data sets as the automotive landscape evolves. And the adoption of more advanced machine learning models could also refine our predictions and prescriptions, uh, which like driven even greater efficiency and performance enhancements can be did and the close remarks, we are always like hoping that the insight shares today will inspire continued innovation and uh, research in the field of automotive technology. Like this journey does not we are hoping not to end here. It's like just another beginning in the quest of sustainability and efficiency in the automotive industry. And that's thank you for your kind attention towards this thoughtful engagement and insightful questions throughout these sessions. We all like excited to see where these findings will take us, and all in the next pursuit of creating a greener and more efficient vehicles. Thank you.